children, we will discuss angle of repose today of Newton's laws of motion. We have solved the problem based on friction on the horizontal surface, kinetic friction, static friction, all those things we have discussed. Now we will take up angle of repose. Angle of repose का significance क्या है, इसका meaning क्या है, पहले वो समझ लेते हैं. Now, on the horizontal surface, right, it is a rough surface and object is kept. Now this surface is being lifted, right? जैसे जैसे इसको ऊपर उठाएंगे, it will have tendency to move down. एक situation ऐसा आएगा कि it will just start sliding down. So the angle at which the object just starts sliding, that is called the angle of repose. हम लोगों ने angle of friction पढ़ा है. Angle of friction, it is the angle made by the resultant of normal reaction and the limiting friction with normal reaction. So on the horizontal surface, right, object is kept and normal reaction is this. Here FL is acting and this is the resultant R, and this R is making some angle theta with the normal. Then it is FL acting backward when force is applied, right? When it is about to slide, at that time limiting friction acts, then theta is called angle of friction, right? This we know, and this angle of friction means tan theta is equal to mu s. That too we know. How do we get this? Because here tan theta is equal to FL upon N. So tan theta is equal to FL upon N. And what is FL? That is mu s. N by N. This N will go. Therefore tan theta is equal to mu s. This we know. That is called angle of friction. And here angle of repose, when this rough surface is lifted, object is kept, and object when just about to slide, right, the angle at that moment is called the angle of repose. So we will see that when the object is here, what are the forces acting on this? Since it is just about to move, at that time frictional force will be the limiting friction, right? So this Fs will be equal to Fl. About to move, at that time this frictional force will be equal to the limiting friction, right? So this mg is acting downward, उसका एक component is direction, this is phi, this angle will also be phi. ये phi कैसे हो जाएगा? This angle is 90 minus 5, this is 90 degree, this angle is 90 minus 5, this total angle is 90 because perpendicular on this surface, so this angle will also be phi. So mg cos phi in this direction, mg sin phi in this direction. Normal reaction due to this surface is n, right? And since it is about to move, this frictional force will be equal to the limiting friction. So in this case, since body is at rest, so net force along this surface will be 0, means mg sin phi will be equal to Fl. And in this direction also net force will be 0 because there is no motion in the perpendicular to the surface. Therefore, we can say N is equal to mg cos phi and mg sin phi, that is equal to Fl. And what is Fl? That is mu s into N, and N is equal to mg cos phi. mg cos phi. Therefore, mg sin phi is equal to mu s mg cos phi. So mg will go, we will get tan phi, that is equal to mu s. tan phi, the tangent of the angle of repose. Here tan theta is equal to tangent of angle of friction. In both the cases we are getting mu s. Therefore, tan phi is equal to tan theta. Therefore, phi is equal to theta. Means angle of repose and angle of friction both are same. The concept of angle of repose is clear, so we will take another bit now. Now we will take another important bit. Body sliding down an incline. There is an inclined plane which is making an angle alpha with the horizontal surface. And when the body is sliding down, then what will be its acceleration? That we have to find. Now you see, weight of this acting downward and component of this weight along perpendicular to this incline is mg cos alpha, because this angle is alpha. Mg sin alpha is acting in this direction. And since surface is rough and the object is moving downward, so in backward direction, kinetic friction will act, because the body will be in motion. When the body is in motion, kinetic friction acts in opposite direction. That is why I have written Fk over here. And normal reaction due to surface is N. Now, since the body is moving along the incline, but in perpendicular to incline there is no motion, therefore normal will balance this mg cos alpha. Therefore, mg cos alpha, that is equal to normal reaction. And since the object is moving in this direction, right, suppose with acceleration a, then net force will be along this. So this force is acting downward direction mg sin alpha, backward force is Fk. Therefore, F net, that is equal to mg sin alpha minus Fk. Backward force, Fk, kinetic friction is acting. And what is Fk? Fk we know, that is mg sin alpha minus mu k n. What is m? Mg cos alpha. Therefore, mg sin alpha minus mu k mg cos alpha. And this F net will cause acceleration in this. Therefore, this is ma, acceleration, downward direction. So this is equal to, we can take mg common, we will get sin alpha minus mu k cos alpha. That is ma is equal to this, m and m will go. Therefore, acceleration is equal to g sin alpha minus mu k cos alpha. So, when the object is sliding on the rough inclined surface without any other external force except gravitational pull, in that case acceleration caused by this gravitational force will be equal to g into sin alpha and mu k cos alpha. Right? See another bit, that is work done in sliding a body on horizontal surface. This is the rough surface, object is kept over here. Now some force is being applied, and this force does not cause any acceleration. How? This force is equal to the backward force, that is kinetic friction acting on the object. Both forces are balanced. It is, when it starts moving, it moves with constant velocity. Right? In that case, what will be the work done? You see, force applied over here, weight of the object is acting downwards. Normal reaction due to this surface on the object is N. Therefore, N is equal to mg. Right? There is no vertical motion of the object. It is moving horizontally. And due to this force, since backward force is equal to the applied force, therefore F is equal to Fk. And it is causing the constant velocity in the object and has moved a distance of s. Right? So what is Fk? Fk is mu k into n, that is mu k mg. the applied force is equal to mu k mg, and it does not cause any acceleration. It moves with a constant velocity and constant force is acting on this, right? Because Fk is always constant. If same force is acting on this, so force will also be constant. We know when the force, constant force is acting, then the work done is equal to F dot S. Or since in the same direction it is moving, so we can say F into S. Therefore, work done is equal to F dot S. Here, F S cos 0 degree, because direction of force and direction of displacement is same. Therefore, angle between force and the displacement is 0. So, therefore, it is simply Fs, because cos 0 is 1. And what is F? That is mu k mg, that is mu k mg into S. Therefore, work done is equal to mu k mg S. This is the work done by the external force, which is equivalent to the kinetic friction, is equal to work done is equal to mu k mg into S. It is for the horizontal surface. If the surface is inclined, then what will the work done? We will look at. See, this is another case. When the object is on the inclined plane with coefficient of friction, static friction in µs and kinetic friction is mu k. When certain force P is applied on this and it is moved from A to B, displacement along the incline is S. इसके along जो displacement है S है, so how much work is done by this force P? Here this force P, which is applied on this object, it is just sufficient to overcome the force and it comes in motion. इसमें इतना ही फोर्स लगाते हैं कि जस्ट इसमें मोशन शुरू हो जाता है and it moves with the constant velocity. There is no acceleration in this. जो फोर्स लगाएंगे, इसके बैकवर्ड फोर्स इज एक्टिंग, that is Fk, kinetic friction, as well as component of weight along this. So इन दोनों को ओवरकम करके ये फोर्स P जो है इसको मूव करेगा ऊपर के डायरेक्शन में along the incline, right? So this force is sufficient to overcome these two forces and body comes in motion and is shifted up to the position of B. So force P will be equal to what? These two forces are acting, mg sine theta plus kinetic friction. And here the normal reaction, in this direction there is no motion, therefore normal reaction n is equal to mg cos theta. So we can put the value of Fk in this case, that is equal to mg sine theta plus mu k into n. Therefore, P is equal to what? Mg sine theta plus mu k mg cos theta. So this much force is acting in upward direction and displacement is x along the direction of force. Therefore, work done, that is equal to Ps. That is, we can take mg common from here, that is sine theta plus mu k cos theta into S. This is the work done by the force P when the object moves along the incline in upward direction, right? And when it comes down, we will find the work done by this force P when it comes down. Now see, another case, work done in moving a body down the incline. This is the rough surface, object is kept over here, some external force is being applied. Apart from the gravitational pull, P is applied to move the body from A to B by a displacement of S. Then what will be the work done? Now, since external force is required to move, it means this frictional force, kinetic friction, is more than that of the gravitational force along the inclined plane. Means net force, that is Fk minus mg sin alpha, is acting upward, equal force is applied so that there will not be any acceleration in the mass, and with the constant velocity it will be coming, then what will be the work done? This constant force will also be working on this. Here F net will be in upward direction, Fk minus mg sin theta, Fk minus mg sin theta. This is upward, in upward direction, along the incline in upward direction. Now the body is moved, so external force P is applied, and that must be equal to this, so that it will move with the constant velocity. Therefore F net is P, that is equal to Fk minus mg sin theta. Again Fk is equal to mu k into n minus mg sin theta. Here n is equal to mg cos theta, isn't it? Mg cos theta, because there is no motion perpendicular to the inclined plane. Okay, therefore mu k into mg cos theta minus mg sin theta. Therefore P is equal to, taking mg common, that is mu k cos theta minus sin theta. Therefore work done is equal to P into S, because force and displacement both are in the same direction, displacement is S. Therefore mg, that is mu k cos theta minus sin theta into S. This is the work done by moving the object down the inclined plane. So we will take a few numerical problems. So first one, you look at it. A cube slides down the rough inclined plane of inclination theta with constant velocity. If this cube is projected up the plane with velocity v0, then at what distance along the inclined plane the cube will come to rest? So conceptually we will go. What is given? This is an inclined plane. Object is kept on this. It is a rough inclined plane, and this angle is theta. Right? And since it is moving with constant velocity down the plane, inclined plane, then kinetic friction will act. Fk will act in upward direction, and it is coming down, right? So what are the forces acting? Fk upward, it's mg is acting downward. Since this is theta, so this angle will also be theta. Along this and along this, if this mg is resolved, then perpendicular to this inclined plane, it is mg cos theta. Along this is mg sin theta. And a normal reaction due to this inclined plane will be working in this direction. Right? Now, since the object is moving along this inclined plane with constant velocity, it means there is no acceleration. Since there is no acceleration, so net force acting on the object along this plane has to be 0. Therefore we can write mg sin theta minus Fk, that is equal to 0. Therefore kinetic friction Fk is equal to mg sin theta. So we got the kinetic friction acting on the object in upward direction, means when it is in motion with constant velocity, then kinetic friction is mg sin theta. Right? Now second case, it tells when the object is moved upward with certain velocity v0, right? Then after what distance it will come to rest, right? So when it is moved upward, so we will make another diagram to make you understand. अभी बच्चों देखो, in the second case क्या बोलता है ये? When it is projected up the plane, यहां से velocity v0 से ऊपर प्रोजेक्ट किया गया, एक वेलोसिटी दी गई और उससे ऊपर के डायरेक्शन में प्रोजेक्ट किया गया। अब इस वेलोसिटी से जाने की कोशिश करेगा, राइट, लेकिन उस पर एक दो फोर्स एक्ट कर रहा है, mg sin थीटा, दिस इज कांस्टेंट बिकॉज मास इज कांस्टेंट, gravitational acceleration is constant, theta is constant, so mg sin theta is constant, and it is a kinetic friction which is also acting downward, this is also a constant. Kinetic friction हमेशा constant रहता है, means constant force is acting on this mass. When it is going up, a constant force is acting. So backward force which is acting on this, how much force is acting? So backward force, net force acting, so F is equal to mg sin theta plus fk. This much force is acting downward, and this is a constant force, so this will cause retardation because going up and backward force is acting. So this force is equal to mass into retardation, acceleration a in backward direction, that is why it is called retardation. That is equal to mg sin theta plus fk. It is constant, and that is equal to mg sin theta. We have got it from the first case. पहले केस से हमने fk का वैल्यू निकाल लिया है, वो यहाँ पर रख देंगे. So that is mg sin theta. Therefore m will go. Therefore वो retardation जो है that is 2g sin theta, and this is a constant retardation. अगर ये रिटार्डेशन कांस्टेंट है तो हम वहां पर इक्वेशंस ऑफ काइनेमेटिक्स यूज कर सकते हैं. सो यहां वेलोसिटी v नॉट थी, यहां पर फाइनल वेलोसिटी 0 हो गई, डिस्प्लेसमेंट इज s, सो वी कैन यूज वन फॉर्मूला, दैट इज v स्क्वायर इज इक्वल टू u स्क्वायर माइनस 2as. माइनस क्यों? क्योंकि उसमें रिटार्डेशन है. रिटार्डेशन कितना है? 2g sin theta. So initial velocity was v naught, and finally it stops. How much displacement is there? That is s, so we can use it. Therefore final velocity is 0, initial velocity is v naught, so we can write v naught is square minus 2 into this retardation is 2g sin theta, so we will write 2g sin theta, and displacement is s. From here we will get displacement as v naught square upon 4g sin theta. So what is asked in the question? What is the displacement? So this will be the answer, that is v naught square upon 4g sin theta. Right? Concept is clear. I think you have understood well. So we will take another question. See children, another question. A girl pulls a loaded sled of mass 75 kg along a horizontal surface at constant velocity. The coefficient of kinetic friction between the runner and the snow is 0.10. Then what is to be found out? Calculate the tension in the rope and what is the normal force with which the snow pushes vertically up on the sled. Now you see, this is the snow surface, this is the sled, and these are the runners. Runners are these. So what is required? What is the tension? A girl is pulling, this is the rope, and suppose the tension in the rope is T, making angle theta with the horizontal, and this theta is also given, that is theta is 37 degree, right? Then it is moving with constant velocity. Here velocity v is constant, it is given. Then we have to find the what is tension and the normal reaction force on this sled. Okay, so we will draw the forces acting on the sled. Its weight is given 75 kg, then 75 g is acting downward on the sled. What is the normal reaction? That is n is acting. Now since this tension is making certain angle with the horizontal, so we will resolve this tension. One in this direction, another in perpendicular direction. Along this will be t cos theta. Along this, that is t sin theta. Now this t cos theta will make the sled to move forward, right, parallel to the snow. and these two forces will balance this weight because there is no any kind of vertical motion in this leg. So we can make the equations and accordingly we can find tension as well as the normal reaction. So solution. See, normal reaction plus this force is balancing the weight of it. Therefore we can write N plus T sine theta is equal to 75 G. With this we can find the normal reaction. Therefore N is equal to 75 G minus T sine theta. Normal reaction is known now. T cos theta is giving some velocity, and that is the velocity is constant. Since it is moving, it is in motion, it means some force will act, that is kinetic friction will act on this, and net force must be zero because it is moving with constant velocity, right? Therefore we can say T cos theta that is equal to Fk. बोल सकते हैं forward force that is T cos theta, backward force Fk, both should be equal and net force must be zero, then only it will move with constant velocity. कोई वेलोसिटी मिल गई, उसी वेलोसिटी से चल रही है, इसका मतलब क्या हो गया कि there is no acceleration. If there is no acceleration, the net force along this must be equal to zero. Means T cos theta minus Fk that is equal to zero, means T cos theta is equal to Fk. ठीक है? Fk क्या है? That is mu k into n. What is mu k? Mu k is given, that is 0.1 into n. Therefore T cos theta is equal to 0.1 into normal reaction we have got over here, that is 75 G minus T sine theta. Now I'll put the values. Theta is known, 37 degree. We can put the value of cos theta and sine theta, then we can find the value of T. See, standard angle, this is 37 degree, this is 3, this is 4 and this is 5, right? So put the values. Therefore T cos 37 degree is equal to 0.1 into 75 into 10 minus T sine 37 degree. Value of G I have taken as 10. So put the values. Therefore T into cos 37, it is 4 by 5 is equal to 0.1 into, that is 750 minus T into sine 37, 3 by 5. Further simplification, we will get the value of T. So therefore 4T by 5, that is equal to, if you multiply, we will get 75 minus 0.3T upon 5. So further we can write like this, 4T by 5 plus 0.3T by 5 is equal to 75. Therefore 4.3T is equal to 75 into 5. Therefore T is equal to 75 into 5 upon 4.3. So this is equal to 87.2 Newton. So we got the tension and we will find the normal reaction. So put the value of tension over here, we will get the normal reaction also. Now normal reaction is 75 G minus T sine 37 degree. So we will put the value of T and we will get the value of normal reaction. Second case, that is B part. That is equal to 75 into 10 minus T is equal to 87.2. That is 87.2 into sine 37 is 3 by 5. We will simplify 750 minus multiply by 3 6 that is 261.6 by 5. Further simplification, 750 minus, if you divide it by 5, then we will get that is 52.32. So that is equal to 697.68 Newton. This is the normal reaction. So this way we have found the tension, the first case, normal reaction of the second case. So this is the solution of these two questions. So we will take more problems later and we will meet again. Till then, all the best. Take care of you. Study well. Be sincere. More and more problems you solve. On my behalf also I will try to give you the maximum number of problems. ज़्यादा से ज़्यादा problem solve करने की कोशिश करेंगे. फिजिक्स में particularly मैकेनिक्स पार्ट में जितना आप प्रॉब्लम सॉल्व करेंगे उतना आपका कॉन्फिडेंस बढ़ेगा और ज्यादा कंसेप्ट ज्यादा क्लियर होते चले जाएगा. ठीक है, इसलिए करते रहिए, पढ़ते रहिए, दिल लगा के पढ़िए और आगे बढ़िए. ऑल द बेस्ट. टेक केयर ऑफ यू.